Welcome to Fortopia. So we are going to be visiting the land of Fortopia, and so we need to exchange money. In Fortopia they have the following paper money. They have a $1 bill, a $4 bill, and a $16 bill. So if we have $53, how could we have the fewest Fortopian dollars? And so to do this, let's think about our largest bill first. How many 16s do we have in 53? Well, this is a division problem. 53 divided by 16 is 3 and 5/16, or 3 with a remainder of 5. So that means we need 3 $16 bills. Well, we have $5 left over. So with the $5, I could have one $4 bill and then one $1 bill. So the fewest number of bills we have is a 3. We have 3 of the $16 bills, 1 of the $4 bills, and 1 of the $1 bills. This model, you could try different money values and see what you're getting for your bills. Again, it's an easy way to think about your largest bills first. Which ones do you have to fill in? The Fortopian money system is actually a model of base 4. Base 4 is using the digits 0, 1, 2, and 3, and our place value is based on groups of 4. When you think about those bills that the Fortopians have, they have a $1 bill, a $4 bill, and a $16 bill. The $16 bill is 4 groups of 4. So that's 16. We could also look at base blocks, just like we did in our Hindu-Arabic system, which I called base 10. We could call the unit 1. Now a long is going to represent a group of 4. A flat will represent 4 groups of 4, or 16. And a block is going to represent 4 groups of 16, which is 64, or 4 cubed. So looking at our place values, the 1's place is 4 to the 0. The 4's place is 4 to the 1. The 16's place is 4 squared. And the 64's place is 4 cubed. If we were to look at our Fortopian dollars that we had 3 groups of 16, 1 group of 4, and 1 group of 1. In base 4, we would write the number 331, and then we write this little subscript of 4 to tell us that we are in a base 4 system. And so we'd have 3 flats, 1 long, and 1 unit. And so that's 3 groups of 16 plus 1 group of 4 plus 1 group of 1, and that adds up to 53, which is what we had started with before. We had $53 to start with. So as you can imagine, we can have a base B system for any value of B, as long as B is a whole number that's bigger than 1. And so our base 10 system, we have 10 digits, 0 through 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and our place value is based on groups of 10. So if we look at the general base B system, we have the digits 0, 1, 2, up through B minus 1. And then our place value is based on groups of B. So once you get B things together, you're going to move on to the next place value. So you can also draw pictures, which I showed in the base 4. The unit is equal to 1, which is B to the 0 power. A long is a value of B to the 1 power. A flat is B squared. Think about the area of a square, B times B, B squared. And then the block is B cubed. And think about the volume of a block. It's B times B times B. So we'd have 3 dimensions in B cubed. So what we're going to do now is look at a couple of examples that are a little bit more standard. Before we move on, because our next example is going to talk about this, digits must be a symbol that uses only one position. So if you use a digit that takes up two positions, it might be confusing. Are we talking about which place value are we looking at? So, with that in mind, let's think about a base 12 number system. In a base 12 number system, we're going to have the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Notice that I'm not using 10 written as 1, 0. Because if I use 1, 0, that takes up two positions with digits I've already used. So does 1, 0 represent one group of 12 and 0 ones? It's confusing. So I'm going to use the letter T to represent 10. The same note, 11, I need to represent with a single symbol. And so I'm going to let E represent 11. So place value based on groups of 12. Okay? Think about the commonalities with what's going on in our base 4 system, base 10 system, which we've used since we were young children, and now we're looking at base 12 system. So if I look at the number T47 base 12, and that's how we read our numbers, we just read the digits from left to right and then we say the base. So T47 base 12. Well, this is a 3-digit number. If I were to think about the symbols to write this number, I have it down at the bottom. I'd have 10 flats, 4 longs, and 7 units. My 10 flats have a value of 10 times 12 squared. Because a flat, place values based on groups of 12, a flat has a value of 12 squared. So I have 10 times 12 squared. That represents the T in the third position to the left. Then we have 4 times 12. These are our longs. Each long has a value of 12. And then I have 7 groups of 1. 7 times 12 to the 0. Those are my units right here. So in a way, what we're doing is breaking apart these base 12 blocks. What if I were to break them all up into small little units? Well, each of these flats could be broken into 144 small units. Each long can be broken up into a small unit. And then the units are already units, so we're going to add all those up. We have 1,440 plus 48 plus 7, and this number, T47 base 12, has a value of 1,495 in our number system, if we were to think about that number. If I do not write a little word down here to say what base we are in, then you assume that we are in base 10. If I don't write a number down or a word down here, it means we're in base 10. So one activity is to look at the next numbers, like how do you count? So when we think about counting, we're just going to be adding units. And so I'm going to add them in blue. Oops, I'm going to switch colors to another blue. And this number has 10 flats, 4 longs, and 8 units. And I would write that as 10, 4, 8, base 12. I can add another unit. So this is 10, 4, 9, base 12. I can add another unit. Notice I have 10 units, so this is 10, 4, 10, base 12. I can add another unit. Now I have 11 units. 10, 4, 11, base 12. So we've added 4 numbers. We're going to keep going. And now I add another unit, and there are 12 units here. And so we're going to be doing some regrouping. These 12 units become another long. So my next number is 10, 5, 0, base 12. These 12 units get regrouped into one long. And then the next one after this. So these guys are all gone. I'm going to erase them. This step is important for you to show where you have it circled and an arrow where you've gone to the long. And now, at this point, I add another unit. And this is the number 10, 5, 1, base 12. Okay, so just getting familiar with how the regrouping works. Drawing pictures can be very, very handy. Actually working with the manipulatives is also handy. If you create yours using paper, or we have Unifix blocks or something like that, you can really get your hands on what's going on. And the final one I want to talk about is base 2, which is binary. We have the digits 0 and 1. Place value is based on groups of 2. So binary has very little to work with. You only have 2 symbols, 2 digits, 0 and 1, but things change quite quickly. If I start counting, I have 1, 1, 0, 1, 1, and I was lazy when I wrote this. I need to write 2 at the bottom of all of these.
Why don't you take this, because I'd rather, I think that's the top as the top of that.
And so if we wanted to write 43 in binary, let's think about our place values. It's based on groups of 2. So 1s, then the 2s,
Stay cool.
and then 2 groups of 2, which is 4, and then 2 groups of 4, which is 8, 2 groups of 8 is 16, 2 groups of 16 is 32, 2 groups of 32 is 64, and so on. The largest place value we need is 32. So how many 32s are in 43? Well, there's one of them. 43 minus 32 is 11, so I have 11 left over. So now we're going to look at our place values as we go down. I have 0 groups of 16 in 11. That's what I have left over. 43 minus 32 is 11. I have 1 group of 8 with 3 left over, so that's 0 groups of 4, 1 group of 2, and 1 group of 1. And so 43 would be written as 101011 base 2.